So Red Hat announced last year at the Open Infra Summit that we'll be pursuing a method of deploying OpenStack on top of Red Hat OpenShift. So that has been my primary focus for the start of 2023. I've been working on the Heat operator and the Horizon operator, along with a couple of things that contribute to the external data plane management. So the data plane will be managed externally to OpenShift. So you'll import all of your compute nodes and they'll be managed by Ansible, similar to how TripleO would manage a compute node. But in this video, I want to take a look at the control plane. I need to redeploy mine because changes happen so frequently in this project that, I deployed mine 3 weeks ago now. They're probably so far out of date that nothing that I'm testing is relevant. And that's going to be a similar experience for anyone who watches this video as well. By the time you see it, everything I tell you here will probably be outdated. So, I make no guarantees that this will work for you the same way I'm explaining here. But my intention is really just to show what this looks like once it's deployed, how you interact with it, some of the various things and how they come together, how you provision that control plane. And I'll show you what it looks like from the console as well. Ultimately, the experience will be that you install the operator in the OperatorHub, create an instance of the OpenStack control plane and OpenStack data plane, and that will provision your OpenStack environment for you using Kubernetes operators for the control plane, and the operators will also manage that Ansible lifecycle of your external compute data plane as well. So if we swap over to the terminal, we have this repository on the OpenStack K8's operators project on GitHub called install YAML. So I'll just zoom in as well, make it a bit easier to see. So in this install YAMLs directory, there's a make file. And in the make file, you can use that to deploy any of the individual operators, but the way we're going to look at today will just be with the OpenStack stuff. So we'll deploy close to how you would once this has actually been released. So the first thing I'm going to run is this make OpenStack prep. And that creates a few files in this directory here. So we ls that directory. We can see we've got a catalog source, an operator group, and a subscription. And this is all we really need to get started. So for me in this environment, I am using NFS shares for my persistent storage. So I'll just go OC apply that so we can see here now that we have these persistent volumes that are available. And I'm just going to quickly log in and just wipe those so we get rid of the existing databases and anything else that might be stored there. Okay, so once that's done, we're going to run make OpenStack prep, and that will go and create some files in this directory. So we do an ls of that directory. We can see we've got a catalog source, an operator group, and a subscription. So we'll do oc apply-f on that directory, which will go and create those objects in the cluster for us. So we can see there we've got the operator group. That creates a pod, which is this index pod, which contains the database of everything that needs to be deployed. Okay, so that runs an install plan that starts to set up our CSV. So this pod here, it's a job, get job. So we set out job. So this pod's running and it's going to set up everything we need for the CSV. So once that has finished, which it looks like it has, we can do OC get CSV, and we have this OpenStack operator CSV. So now at this point, my server behind me is going to get really loud, start to deploy a whole bunch of pods. And the pods that it's deploying are basically the operators that we've written. So it runs the pod and then it starts the operator, and the operators will be looking out for the various resources that match their definitions. So, Neutron will keep an eye out for the Neutron resource, etc., etc. So we need to wait for those pods to come up and be available, and then we can go and create our OpenStack control plane object. So we have a look at the OpenShift console at the moment. We can see that we have the OpenStack operator that has now been installed, and this is how you'll interface with it. You don't need to do anything through the command line like I just did. It'll just be an OperatorHub. You can install OpenStack. That gives you 2 custom resources that can be deployed. The OpenStack control plane, which is they're all the Kubernetes operators. They all run on top of OpenShift. And the OpenStack data plane. So what that will do is it will create a bunch of custom resources that represent physical compute nodes in your environment, and it will run Ansible playbooks from the Ansible operator against all of those compute nodes to configure them however we need to. In this video though, I'm just focusing on the control plane. That's all I need to keep testing horizon and heat operators. So we can see an example here of what the definition of an OpenStack control plane looks like. It contains each of the OpenStack services you're familiar with. All of our images are built on OOZ, so the Z stream of OpenStack. See Galera, Glance, Ironic, etc., etc. So we create that, and it creates all of these definitions for the services, and each of the service operators are looking for those definitions, and they will go in and reconcile accordingly based on the information that we provided here. So at the moment, we just need to wait for those pods to become available, and we can see they're all starting up here now. MariaDB has complained about something by the looks of it. Right, so what's happening here is this is from a previous deployment, and it has a deletion timestamp on this resource. So what we need to do is we need to actually get that deleted, and then we will be fine to start up again. So we'll do OC edit MariaDB. And this happens because I deleted the operator pod before the resource, so there was actually nothing to clean it up. So we just removed the finalizers. Okay, so we just cleaned everything up, and we'll just do an apply again, and we'll start from scratch, which creates a pod. So once this pod's up and running, it will launch a job, and that job will set up our CSV that will go and then provision everything else. So now that that's done, we can see the CSV here, the OpenStack operator CSV. So that's going to provision all of the pods we need to actually deploy this in our environment. Okay, so we can see these pods are starting to be created now. So keep an eye on the time in the bottom right hand corner as well while we do this, so that it doesn't take very long at all to get this control plane up and running. So we'll wait for them to all be running. Now we're just waiting for everything to be ready. So we've only got one of two for example. Just do it a bit longer to get everything up and running and everything ready. Okay, it looks like everything is ready there now. So the next thing we need to do is actually create that instance of the OpenStack control plane. Now, with the install YAMLs, we can do that just by running OpenStack deploy. So make OpenStack deploy. That'll create the instance of the OpenStack control plane. Go OpenStack control plane. You can see it there. Now, I'm just going to edit that really quick because I don't want to deploy Cinder in my environment. I don't have any backend storage that I can use here. So we're just going to set Cinder to false. And now what's going to happen is it's going to start deploying all of the services required for that control plane at this point. So if we just check back in with this every now and then, we'll see it start to run through each of those steps. Now each service will create its own DB init container, which will initialize the database for each service. So we do OpenStack get MariaDB. We can see we have an OpenStack MariaDB, and we do databases. We can see the services are starting to create those databases that they're going to use as they run. So rather than queue starting up here now, let's see what's going on with this DB init container. So I don't think I cleaned up the PVCs very well. Okay, so I need to delete this persistent volume. So it's remnants of my last deployment that's creating these problems. So we'll just recreate that. So you get PV, PVC. Okay, so it's bound there now. So we do get pods again. Okay, so now that DB init container has finished executing, and we can see everything else is now starting up. So MariaDB OpenStack starting up. And once that's up and running, we can start to get the rest of the services. So we'll just leave this for a couple of minutes, and we'll check back in once it's been deployed, and I'll show you how to interact with the control plane. Okay, so we got a bunch of completed things there. So the way we can tell if it's ready is just to get OpenStack control plane, and it reports a bunch of statuses. So everything will start to report ready as it becomes ready. And if we have a look back over here, at the OpenStack control plane instance, we can see we've got everything there is now reporting as ready. So to interact with this control plane, what we have is a couple of secrets with the passwords in them. So we do OC get secret. We can see we have this OSP secret here. So this one just contains the passwords that are in use. So as each service creates its database, it has a database password that is used, and we're just using the same password for everything in development. The other one is this OpenStack config secret. So we do get secret, OpenStack config secret, JSON path data. We can see we have this base 64 encoded string here. And if we do a echo pipe to base 64-D, we can see that it gives us a clouds YAML file. So I've already set this up, so what we need to do is just export os cloud equals default, because that's the name of our cloud there. And then we can do OpenStack endpoint list, for example. Okay, so I have a problem where Keystone isn't being deployed, and I'm going to show why that is. So we have a look at the Keystone resource here. You can see everything's reporting as ready, but it has a deletion timestamp, and this means that this resource is trying to be deleted, but it hasn't been deleted yet. So if we just edit this resource, and we just remove the finalizers from it, so that's now deleted it, and it's created a new one. So you can see this one doesn't have the deletion timestamp. And if we check out our pods again, we can see now we have Keystone here starting up properly. Still waiting. This one's only here 7 seconds, so we'll give it a bit more time. Okay, here's the actual Keystone starting. So once this service is up, we'll be able to run the OpenStack endpoint list and get a response back. So that's, I might be a little bit early still, a bit ambitious. Okay, there we go. So we can see that the endpoints are there now available, and as we wait a little bit longer, the other endpoints for the other services will also become available. So we can see there we're getting more and more endpoints in our endpoint list. So a lot of the issues I've run into with redeploying are just results of remnants existing in the cluster and not being cleaned up properly by me. So if you're deploying on a fresh cluster, you shouldn't run into the issues that I'm having here. It's just because I keep using the same cluster and over and over and over again. A lot of the development is happening in CRC, so you can just blow away the code-ready containers, VM, start it up again, and redeploy, and you shouldn't run into any of the issues with existing resources. So yeah, I mean, look, we're interacting with the OpenStack API there now. We can see that the services get created fine. Have a look at our pod list. We can see that we're getting an ever-increasing list of pods here. If we do something like OpenStack network agent list, we can see that we have the OVN controller agents running on the 2 worker nodes in my cluster. So this is a 5-node cluster in my case. So I have 3 control plane, 2 worker. So this statement set would clone all of your worker nodes in the environment and field traffic coming from the data plane as necessary. So we'll take a deeper look at how networking and everything works in a future video. The point of this one is really just to show what this looks like once it's been deployed, which is essentially this. This is all the pods that we need for the control plane. Then we have things like the data plane operator, which will field in those data plane, which will field the OpenStack data plane custom resource and all the nodes that you need, and then that leverages the Ansible execution environment to run the playbooks against the compute nodes. So just a really quick video today. I just wanted to show what it looks like once the OpenStack control plane is deployed, and what that looks like through the OpenShift console, for example, how we have the operator from OperatorHub and then the single instance of the OpenStack control plane that then creates everything else based on the templates in that custom resource definition. So look, as I start deploying the data plane and adding my server as a data plane node, etc., I'll make more videos and show things as they come up. I'll try and pick things that are relatively stable. So like this should work a lot of the time, but things are going to change. I wouldn't rely on it working. I would definitely not use it as a production deployment of OpenStack at the moment. Definitely if you want to test though, I'll have all the links below and everything we discussed in this video so you can give it a try and see what it's like. If you have any questions, hit me up below. I'm happy to have a chat about it. Happy to share more information, share some of the resources I'm using. Anything specific that I might be able to help you with, feel free to let me know.